Welcome. In this video, I'm going to talk through this Prezi that talks about using Kool-Aid to study solubility. So first things first, I didn't create this Prezi. It's something that I found online, so I always want to make sure I give credit where credit's due. When we look at some vocab, so we've got a solute and a solvent. So we're talking about solubility. Notice that these all have the same root. So I'm just going to keep using two examples. I'm going to use salt and water, and then I'm going to use Kool-Aid and water. So those are the two things that I'll use as I talk through this. So in the Kool-Aid example, the Kool-Aid is the solute, the water is the solvent. So, so you can imagine in the salt and the water one, which one is the solute and which one is the solvent. The solute is the thing that dissolves into the solvent. So, maybe you know about oil and water not mixing. Well, there are things that oil can act as a solvent for, things that can dissolve into oil and things that can dissolve into water and things that cannot dissolve into the others. So, the solute, again, is what's being dissolved. The solvent is the thing that's absorbing the solute. So there's a picture. There's another picture of the solvent. Again, I didn't make this. Quickly, this is a really important thing that I feel like I've done a bad job of teaching. I've definitely done a bad job of making you memorize this throughout the year. We should be using grams to measure mass. Now, when you're at home, I don't expect you to be able to measure mass in grams. Maybe you have a kitchen balance, a kitchen scale that measures in ounces or something like that, but probably not. Most people don't. Liters are what we use for liquid measurements, and then solubility. So since we have those, solubility is going to be the maximum amount of solute that can dissolve in 100 grams of the solvent. So again, the numbers behind it aren't going to be important for our lab purposes. We're going to say solubility is the maximum amount of powder that can dissolve. So, maybe we need to mask that. Maybe we need to use 1 packet, 2 packets. You got to do a little bit of troubleshooting on your own, figure out how to make this work. But we'll talk more about that with the lab. And this does talk about the lab. This Prezi does a little bit. Well, we're doing a similar kind of setup. Again, I didn't make this Prezi, so it doesn't match perfectly. Another important vocab, set of vocab is a saturated solution, an unsaturated solution, and a supersaturated solution. So what we're talking about, is what level of dissolved are we? So if a solution is unsaturated, that means that it can still absorb more. You see in parentheses there, they talk about nasty Kool-Aid. So an unsaturated example of Kool-Aid would be really light Kool-Aid. So you can still add more and the Kool-Aid can still get darker, right? Or maybe you don't add enough sugar. Maybe it's not the color, but it doesn't taste sweet enough. Well, you can still add more and it'll still dissolve in. Once you hit that point where you put a little bit more sugar in and it won't dissolve, a saturated solution is right at that perfect level. It's right at where the last granule of sugar will dissolve, but we couldn't add one more. That's a saturated solution. And then last but not least, a supersaturated solution. We're going to do a lab with that at the end of this unit. A supersaturated solution is that there's more solute dissolved in the solution than the solution can handle. So we're going to have to find some way to manipulate the solubility of the solvent so that it takes in more than it can handle, and then we'll restore it to normal, and we'll see what happens. When I say normal, I mean I'm trying to not give away the fun part of the lab. So you'll see. I did not realize that was zooming in, so let me click through that quickly. So I really like this picture. I think I used this picture in class at one point. At some point you guys have seen this picture. So this shows a really good serial dilution. So what we would do to make this from a chemistry perspective is we would make the darkest Kool-Aid, we would make it as saturated as we could, super saturated even if possible. And then we would take a little bit out of this darkest one and add more water. And then take a little bit out of this one and add more water. Take a little bit out of this one and add more water. Take a little bit out of this one and add more water. And that's called a serial dilution because you're serially deleting it. Like a TV series is called a series because there are episodes, like one episode follows another. So this is a serial dilution because you're diluting them one after another. We're not doing a serial dilution. That's just an important thing that comes up in this topic. That's one of those things that if we were in school, we would be spending a lot more time on it than we are now. Likewise, heterogeneous versus homogeneous. We talked about this forever ago, maybe Unit 1, maybe Unit 2. But a heterogeneous mixture is going to be something that has different components. Hetero always means different. Heterosexuals are attracted to a different gender. Heteronormative. Hetero always means different. So a heterogeneous solution is going to be one that's multiple things mixed together. A homogeneous solution is only one thing. So that would be like pure water. That's the picture I got there. Pure gas, O2, something like that. Still considered a homogeneous solution because it's a liquid. So this is the recap slide. Remember, solubility is all about dissolvability. So if something has a high solubility, then that means that a lot of something can dissolve into it. If it has a low solubility, not very much can dissolve. So I expect there to be challenges with the labs as you move through them. Like I said in the project intro video, I want the labs to be fun. I really want this unit to be something that is, okay, maybe fun is a stretch, but I don't want it to be painful. Is making Kool-Aid really fun? I don't know. It's not fun. It's a tasty treat afterwards. I don't know. So I really do want this to be fun and enjoyable for you and your family. So keep grinding, keep working at it, guys, and shoot me questions when you have them. Proud of the work you've done so far. Keep it up.